Tanisha Singh. My fascination with the universe began in high school when I came across an issue of Science News. Intrigued, I read the entire article, even though I didn't fully understand it at that time. The James Webb Space Telescope was about to launch, and that event sparked my curiosity. Fast forward 3 years, and I have gained a wealth of knowledge from my class on our place in the universe. This slide shows the planned timeline of 180 days from launch to readiness. Despite numerous challenges, the James Webb Space Telescope mission was a resounding success, thanks to the dedication and expertise of our NASA scientists and engineers. The James Webb Space Telescope is a giant leap forward in our quest to understand the universe and our origins. It has a massive mirror that has large light collecting area with a significantly larger field of view, making it possible to peer farther back into time and collect light from the faintest objects. It has mobile ways of blocking and dissecting light, giving us detailed portraits of distant galaxies and close neighbors alike. Webb co-rotates with the Earth around the Sun at the Lagrangian L2 point, 1 million miles away from the Earth. Webb telescope works primarily in the infrared range of the electromagnetic spectrum, with some capability in the red to yellow part of the visible spectrum. Infrared light penetrates through dust and gas clouds and revealing what is inside.
Hi, my name is Adriana, and I've known I wanted to be an astronaut since I was 4 years old. I'm going to talk about how we are able to see James Webb images. James Webb Space Telescope images are not representative of what humans would see because they are shot in infrared that detects heat. The colors in the JWST images are ones that are representative of wavelength proportional to the brightness. To create the images, scientists take up to 29 grayscale images through different filters that only pass IR light of certain wavelengths. They then isolate the most useful dynamic range for each image and scale the brightness values to reveal the most details. Then, scientists will assign different colors to the different wavelengths depending on their brightness. The shorter wavelengths with less brightness will be blue, and the longer wavelengths with higher brightness will be red and yellow. The images are then combined and then reviewed to be published.
James Webb Space Telescope has made a lot of discoveries since its launch. We will discuss the discoveries that has excited us the most. This image from Webb combines near and mid-infrared light to show two interacting galaxies known as ARP 142. The image is a captivating sight and reveals that the two are in a cosmic dance, joined together by a blue haze of stars and gas. At left is elliptical galaxy NGC 2937, which looks like a large blue oval and is nicknamed the Egg. Its center is the brightest and most opaque, taking a whiter hue. At right is NGC 2936, a distorted spiral galaxy nicknamed the Penguin. The gravitational forces have reshaped the Penguin galaxy, giving it a distinctive appearance that resembles a penguin with a beak, head, backbone, and fanned-out tail. This interaction has also triggered waves of star formation, visible as feathers in the penguin's tail. Galaxies Penguin and Egg are not only interacting, but they are on a path to merge and become one bigger galaxy. Their interaction began between 25 and 75 million years ago, and they are currently about 100,000 light years apart. Over the next hundreds of millions of years, gravitational forces will continue to draw them closer until they eventually merge into a single galaxy. By studying images like this, we can understand the processes and the life cycle of galaxies and how two galaxies merge to form another galaxy.
Outside of giving us information to create images, the James Webb also measures temperature. TRAPPIST-1b gives off a thermal emission, which is heat energy given off in the form of infrared light. The telescope's MIRI detected the infrared light and indicated that the planet's day side has a temperature of roughly 230 degrees Celsius, or 500 kelvins. Measurements like this allow us to determine if planets orbiting small stars can sustain life. Previous observations with the Hubble and Spitzer Space Telescope were inconclusive about whether the planet had an atmosphere or not, but with the James Webb we've determined that it does have an atmosphere. The picture on the left has blue squares that represent individual brightness measurements, while the red circles show measurements that are binned or averaged to make it easier to see the change over time. The model on the right takes into account the planet's size, density, orbital distance, and star temperature. TRAPPIST-1b day-side temperature is about 500 K, assuming no atmosphere, no heat redistribution, and a dark surface. If the heat were distributed evenly, the temperature would be about 400 Kelvin. The James Webb has also captured this incredible photo of galaxy NGC 7469 with an AGN region at the center. An AGN, also known as an active galactic nuclei, is one of the most interesting aspects of NGC. An AGN is a region at the center of a galaxy that is much more luminous than the rest of the galaxy and is thought to be powered by a supermassive black hole. In the case of NGC 7469, the AGN is thought to be powered by a black hole with a mass of approximately 100 million solar masses. The strong emission line in the galaxy spectrum are produced by high-energy particles and photons that are emitted from the AGN at the center of this galaxy. Using Webb's MIRI, NIR camera, and NIR spec equipment can show us that there is turbulent molecular gas as well as very immature star-forming clusters that have never been observed previously, and concrete proof that minuscule dust grains were destroyed within a few hundred light years of the AGN's nucleus. This picture just goes to show that the James Webb Telescope is one of the most important observatories for space science in the world.
Ever wondered what the sun looked like in its infancy? Earth's sun looked like this when it was only a few tens of thousands of years old. Hara 211 is located about 1,000 light years away from Earth in the constellation Perseus. This object is one of the youngest and nearest protostar outflows. Protostar is a very young star that is still gathering mass from its parent molecular cloud. HH211 has only about 8% of the Sun's mass. A Class 0 protostar, meaning the nascent star, is less than 100,000 years old. It will eventually grow into a star like the Sun when its core temperature exceeds 18 million degrees Fahrenheit. Hara objects like HH211 are luminous regions surrounding newborn stars. They form when stellar winds or jets of gas from these stars create shock waves by colliding with nearby gas and dust at high speeds. The Webb image is showcasing a series of bow shocks at lower left and upper right, visible in pinkish-orange colors, and a narrow bipolar jet traveling through interstellar space at supersonic speeds. The jeweled ring RX J11311231 is a quasar, located about 6 billion light-years away in the constellation Crater. Quasars are very distant objects that are exceedingly luminous for their angular size. The source of power is the large amounts of gas and dust falling into the supermassive black hole, which heats up and emits intense radiation, causing the region to shine very brightly. The phenomena of gravitational lensing created the stunning, sparkling jeweled ring. Gravitational lensing occurs when the light from the quasar is bent by the gravitational field of a massive elliptical galaxy situated between the quasar and the observer. The elliptical galaxy is the small blue dot in the center of the ring. This bending of light smeared into a brilliant arc, creating 4 distinct images of the quasar due to the intervening galaxy's gravitational field. This quasar allows astronomers to study regions close to its central black hole. The gravitational lensing effect magnifies the light from the quasar, making it possible to observe details. X-ray emissions from quasars can indicate the black hole spin rate, providing clues about its growth history. The black hole in this image is spinning rapidly at over half the speed of light. This suggests a growth process dominated by collisions and mergers with other galaxies, rather than pulling material in from different directions. From revealing the intricate details of black hole growth to probing the elusive nature of dark matter, this discovery underscores the profound capabilities of the Webb telescope. Webb telescope is unveiling the cosmos with awe-inspiring precision, and its revelations are nothing short of extraordinary. These discoveries deserve our admiration and is a testament to the dedication and skill of the team of astronomers behind it. Webb telescope is a win-win for the society. It captivates everyone with its visual splendor and allows astronomers to advance our understanding of the universe. Discoveries made by the Webb telescope are revolutionizing our perspective towards the cosmos and its countless mysteries. It brings to light the infinite potential of human curiosity and ingenuity. Each revelation answers existing queries while simultaneously sparking a new wave of exploration. For example, discovery of jeweled ring helps people understand differences between a quasar and a star. These discoveries are thrilling people and exciting them about the capabilities of the Webb telescope. Temperature measurements of TRAPPIST-1b and X-ray emissions from quasars to determine the black hole's spin rate are exciting and thrilling people beyond imagination. Every discovery increases curiosity in people and increases their desire to learn more about our universe. Learning about protostars and their growth excites and inspires people a lot and even brings tears in their eyes. Images of Webb discoveries with stunning beauty and splendor have excited, inspired, and thrilled a lot of people. A lot of people are using these images as screensavers and computer backgrounds. Microsoft Rewards has been running images of Webb discoveries in their feed. People get to learn about discoveries and earn points at the same time. Since we still do not know about 95% of the universe, it is upon us to educate people that a lot more needs to be done, a lot more needs to be discovered, and we all are in it together. We have enjoyed studying the discoveries made by James Webb Space Telescope. We presented here a small number of discoveries that excited us. We look forward to studying more discoveries and more revelations. They are nothing short of extraordinary. Kudos to all the astronomers, astrophysics, and astronauts around the world for their incredible contributions to our understanding of the universe.